Hello everyone. In the previous class, we have discussed about equality operators, bitwise operators, reduction operators, and shift operators. Today, we will continue with the other operators. So, in today's class, first one is the concatenation operator. So, we have come across the concatenation operator in C programming. Here also in Verilog HDL, the concatenation operation is same as the C programming. So, the concatenation operator, the operator is going to be a curly bracket, open bracket, open curly bracket, and close curly bracket. Within that, you can separate the operands by comma. So that is a operator. So this concatenation operator provides a mechanism to append multiple operands. So you can have more than one operand within the concatenation operator separated by comma. The thing is, the operands must be sized. That is, the size of the operand must be known to compute the result of the size of the result. Without knowing the size of the operand, we cannot use it in a concatenation operator. So the operands, each and every operand must be sized. The size must be known. The unsized operands are not allowed because the size of the each operand must be known for computation of the size of the result. So remember, the size of the operand within the concatenation operator must be known to compute the size of the result. So concatenations are expressed as operands within brackets or braces with comma separating the operands. So operands can be scalar nets or registers. So the type of operand can be either it can be a net or registers, which can be a scalar type or vector type. That is scalar nets or registers or vector nets or registers. It can be also a bit select or part select or sized constant. A constant number can also be included, but sized, it should be sized. So here are the examples. So let's take an example. A is equal to 1 bit binary 1, B is equal to 2 bit binary 0 0, C is equal to 2 bit binary 1 0, and D is equal to 3 bit binary 1 1 0. So these are the given numbers. Now how to do the concatenation? Now observe here, y is the resulting result which holds the result of the concatenation operation. Y is equal to under bracket b comma c. So b and c are the operands within the concatenation operator, which is separated by comma. Now result of this is, first let's compute the size of the y. Y is what? Concatenation of b and c. So b, size of the b is 2 and size of the c is also 2. So 2 plus 2 is 4. So 4 is the size of the y. Now observe, b is b value and c value. B value is 2 bit binary 0 0 and c value is 2 bit binary 1 0. Therefore b comma c result is what? It appends the result into the y operand. So 0 0 and 1 0 together is 0 0 1 0. B is 0 0, C is 1 0. So together it is 0 0 1 0. So result y is 4 bit binary 0 0 1 0 0. 0 0 1 0. That is 4 is the size of y. B is 2, C is also 2. 2 plus 2 is 4. So size of y is 4. Binary number b is 0 0, c is 1 0. Therefore 0 0 1 0. Similarly, the second example, y is equal to a comma b comma c comma d comma a sized binary number 3 bit binary number 0 0 0 1. So concatenation of all these 5 operands a b c d and a sized number. Now first compute the size of the y, result y. So a is 1 bit, b is 2 bit, 3 c is 2 bit, D is 3 bits and the constant number is of 3 bits. So 1 plus 2 plus 2 plus 3 plus 3. So total is 11. So that's why the result of the size of the result is 11. Now append all the bits of A, B, C, D and sized constant together. So it will be 1 0 0 1 0 1 1 0 and 0 0 1. So this is the result of the y. Another example, y is equal to concatenation of a comma b of 0. B of 0 means it is a bit selector. A particular bit of the operand b is selected here. Which bit it is? 0th bit. So there are b is size of the b is 2. So here only 2 bits are there, 0th bit and the first bit. Out of that 0th bit is taken. And c of 1. C of 1 means c is also size 2. Out of that 0th bit and the first bit. The first bit is taken here. So a size is 1. So b of 0, only a bit is taken here. Only one bit is taken out of the 2 bits. So it's also 1 bit now. So c of 1, it's also 1 bit. So 1 plus 1 plus 1. The size of the y is 3. Now observe the result. A is 1. 0th bit of b is 0. And first bit of the c is 1. That's why 101 is the result. Next one is the replication operator. So replication operator is also similar to the concatenation operator. So here repetitive concatenation of the same number can be expressed. In this replication operator, the repetition or repetitive concatenation of the same number can be expressed by using a replication constant. So here a replication constant specifies how many times replicate the number inside the brackets. So it is also same as the concatenation operator, but what it indicates, the same number can be repeated multiple times. How many times, that you need to specify. So we'll see an example how to use the replication operator. So initially you can declare few operands. So register operand A, range of 1 down to 0, B comma C, range of 2 down to 0, D. So these are the registers A, B, C, D are declared. A is equal to 1 bit binary 1, B is equal to 2 bit binary 0 0, C is equal to 2 bit binary 1 0, and D is equal to 3 bit binary 1 1 0. So these are the initial values of the A, B, C and D. Now the use of replication operator. Y is equal to 4 times A. The A value is repeated or replicated 4 times. So A value, size of the A is 1. So 4 times means size of the Y will be 4. Repeat the A 4 times. So Y will be 4 bit binary 1 1 1 1. 4 times it is repeated. Now second example, Y is equal to 4 times A comma 2 times B. Just see how the replication operator is written. Now see 4 times A is 1 bit, so 4 times A means it is size is 4. 2 times B size is 2, so repeating 2 times means again the size is 4. 4 plus 4 is 8. So Y, size of the Y is 8. So 8 bit binary number. Repeat the A 4 times. A is 1, so 1 1 1 1. B is 0. B is 0 0, so repeat it 2 times. 0 0 0 0 is the result. So 1 1 1 1 0 0 0 0 is the result. Now the third example, Y is equal to 4 times A comma 2 times B comma C. C is only one time. Now A is, size of A is 4, size of B is 2, and size of C is also 2. So 4 into 1, 2 into 2 plus C into 1 into 2. So total size is it should be 10. The size of the result is 10. Here by mistakenly it is written 8. Now the result is 1 1 1 1 0 0 0 0 1 0. So A is 1 1 1 1, 4 times A, B is 2 times B, so 0 0 is the value, so 0 0 0 0 2 times. C is 1 0, only one time you have to write, so 1 0. So total result is 1 1 1 1 0 0 0 0 and 1 0. Now the last one, conditional operator. So we have come across this conditional operator in C programming also. The same conditional operator is used here also. The conditional operator is question mark followed by colon. So this is the only operator that takes 3 operands. So usage, syntax here, first condition is checked. So first put the condition and place the question mark. Then when the condition is evaluated, it has 2 values, either true or false value. So if it is true, go to the true expression. If it is false, go to the false expression. True and false expression are separated by colon. Then finally the termination sign. True expression means whenever the condition is evaluated, either it is true value or false value. True value means the value 1, logical 1. False value means logical 0. If the condition is evaluated and it comes true or logical 1, then the following expression, true expression, is evaluated. If the condition is false, then true expression will not be evaluated. It will directly jump to the false expression and it will be evaluated. So the condition expression is first evaluated here. If the result is true or logical 1, then the true expression is evaluated, and if the result is false, that is logical 0, then the false expression is evaluated. That is what we have discussed. There is one more condition here, that is if the result is X or result is unknown, that is ambiguous result, if you get, then both true expression as well as the false expressions are evaluated. Both the expressions are evaluated, and the results are compared here. That is, whatever the expressions, true expression and false expression that are evaluated, their results are compared bit by bit. Then it is going to return for each bit position of an X. Each position and X if the bits are different. If the bits are different and the value of the bits if they are the same. So this is same as this conditional operator is almost similar to the multiplexer. That is, the action of the conditional operator is similar to a 4:1 multiplexer. So alternately it can be compared to the if else expression. So if else, you might have studied it in C programming language. It is also the same. That is, first you have to evaluate the condition. If the condition is true, true part is evaluated. That is body of the true false part is evaluated. If the condition is false, a false body is evaluated. So here 2:1 multiplexer in a schematic diagram. True expression, 1 is the input selected for 1 input. False expression for 0. So whichever is correct, that will be the output. So conditional operator are frequently used in a data flow modeling to model the conditional assignments. The conditional expression acts as a switching control. So here the examples are given. Model functionality of a tri-state buffer. So there is a tri-state buffer here. Assign address bus. Address bus is a result here. We are using a assign as the keyword that is used in data flow modeling. So drive enable, check the drive enable, what is the value. If it is evaluated to 1, then address out is assigned to address bus. If it is false, then it is evaluated to 0, then 36 bit BZ is assigned to address bus. Then the another example, model functionality of a 2:1 multiplexer. Assign out, out is a output variable. Control signal is tested here. If control signal is 1, IN1 is assigned to out. If control signal is 0, IN0 is assigned to out. So conditional operator can be nested also here. So operator within an operator, that is conditional operator within conditional operator, is called as nesting of conditional operator. So each true expression or false expression can be itself a conditional operation here. So in the example is given here. In that, convince yourself that A is equal to 3 and control are the two select signals 4:1 multiplexer with N, M, Y, X as an input and output as the output signal. So as you know, in 4:1 multiplexer, there are 4 inputs, 2 select signals and 1 output. So based on that, this statement is written here. Assign is the keyword in data flow modeling. Assign, out is the output signal. So out is equal to A is equal to 3. Test it whether a value of A is 3 or not. If A is equal to 3, then it is true condition. If it is true condition, jump to the following expression, control question mark X colon Y. So if A is equal to exactly 3, then it will execute this expression, control question mark X colon Y. Now again here there is a conditional operator. So this is called as nesting of conditional operator. Now check again the control value. If control value is 1, then X is assigned to out. If control value is 0, Y is assigned to out. So this is how it is executed. Now if A is not equal to 3, if A is not other than 3, then it is evaluated to false, that is 0. So in that case, it will jump to control question mark M colon N. Control question mark M colon 1 is evaluated because A is not equal to 3. So when this condition is there, again there is a nested conditional operator here, control question mark M is to N. So in this case, again control is tested. If control is 1, then M is assigned to out. If control is 0, N is assigned to out. This is how the nested conditional operator is executes. Next one is the operator precedence. So if no parentheses are used to separate parts of expressions, so Verilog enforces the following precedence. So if you have multiple operators and if you are not using the parenthesis, then the precedence of operator comes into exist. So operators listed in the table. So in there is a table in the next slide. So that list gives you the order from the highest precedence to the lowest precedence. So it is recommended that parentheses must be used to separate the expressions except in case of unary operator or when there is no ambiguity. So if you have any confusion, you can use the expressions within a brackets to provide a higher precedence for that particular operator. So see here, this is the table that gives you the operator precedence. So unary operator has the highest precedence, that is plus, minus, exclamatory sign and the negation. Then multiply, divide and modulus, it is the next precedence. Like this it go on decreasing order, add, subtract, shift, relational, equality, reduction, logical, and the lowest precedence is given for the conditional operator, that is question mark colon. So this is how the operator precedence is given. So within the same operator precedence, within the same group, can evaluate it from the left to right. Whichever operator that comes left side, that will be evaluated first. Otherwise you can put the operators in a parenthesis to avoid the ambiguity. Now we'll see the examples using data flow modeling. The first one is the 4:1 multiplexer. So the 4:1 multiplexer can be written using various logics within the data flow modeling itself. The first one is the using logic equation. So you have come across 4:1 multiplexer in digital electronics. So the Boolean expression for the 4:1 multiplexer is if the output signal is out and the input signals are I1, I2, I0, I1, I2, I3, and select signals are S1, S0 and S1, then the out signal is going to be S1 bar, S0 bar, I0 plus S1 bar, S0, I1 plus S1, S0 bar, I2 plus S1, S0, I3. So this is the Boolean expression. So using this Boolean expression, we can write the data flow model for 4:1 multiplexer using logic equation. So we can use assignment statement instead of gates. In the previous 4:1 multiplexer, that is using gate level modeling, we were used predefined primitives. But here in this modeling, that is, it is a data flow modeling, here we are going to use the operators instead of gates to model the logic equation of the multiplexer. Notice that everything is same as the gate level modeling in the Verilog HDL. Description except that computation of out is done by specifying one logic equation by using operators instead of individual gate instantiation. In the gate level modeling, we were used instantiation, but here we are using a logical equation. Input and output ports are going to be same. That is, schematic diagram for the 4:1 multiplexer is same. So the input and output of 4:1 multiplexer for the any type of modeling, whether it is gate level modeling, data flow modeling, or behavior modeling, it will remain the same. So this is important so that the interface with the environment does not change. Only the internals of the module are going to change. As the type of modeling is going to change, notice that interface with the environment does not going to change. Only the module internals are going to change. So here, this is the program for the 4:1 multiplexer using data flow modeling. So declaration part is going to be same. Module mux 4:1 list of ports out, I0, I1, I2, I3, S1, S0. So separate them, declare which is output, which is input. Output is out, inputs are I0, I1, I2, I3, and again input is S1 and S0. Now instead of instantiation, that is, we have done it in gate level modeling, here in the data flow modeling we are going to use the operators. So assign is the keyword that is used. So as I discussed the logic equation for the 4:1 multiplexer, using that expression that you have to write it in Verilog HDL module. So it will be like this: assign out. So as the Boolean expression for out is S1 bar, S0 bar, I0. So S1 bar can be written as negation of S1 using the in the parenthesis. So this is same expression, that's why I put the parenthesis. S1 bar, that is, it is nothing but a not of S1. Not of S1 can be written as the tidal sign S1, negation of S1. So S1 bar, S0 bar, I0. So here the AND gate is present in between S1, S0 and I0. That's why AND operation. So not of S1 and not of S0 and I0. then plus nothing but it is a OR operator. So followed by OR operator. So write complete Boolean expression in this format. So not of S1 and not of S0 and I0, or not of S1 and S0 and I1, or S1 and not of S0 and I2, or S1 and S0 and I3. This is the program for the 4:1 multiplexer. The second method, the 4:1 multiplexer is used, can be written using conditional operator. So using conditional operator, the declaration part remains the same. That is, you can declare out I0, I1, I2, I3, S1 and S0, and declare the which is output and which is input. Now just observe the logical part. Using conditional operator, we can use you can write the 4:1 multiplexer using nested conditional operator that we have discussed previous example, that is a equal to 3. Similar to that one, here also it is nested 4:1 multiplexer. Assign out is equal to test the condition S1. If S1 is true, then S0 question mark I3 colon I2, this expression is evaluated if S1 is true. If S1 is false, then the last expression S0 question mark I1 colon I0 is evaluated. Now observe, if S1 is 1, then go to the first expression S0 question mark I3 colon I2. If I3 is 1, then sorry, if S0 is 1, then I3 is assigned to out. If S0 is 0, then I2 is assigned to out. If S1 itself is false, if S1 is 0, then go to the second expression, that is false expression, S0 colon I1, S0 question mark I1 colon I0. If S1 is 0, then S0 is 1, then I1 is assigned to out. If S0 is 0, I0 is assigned to out. Like this, all the 4 conditions, that is 0, 0, 0, 1, 1, 0 and 1, 1 for S1 and S0 are tested. According to that, I3 or I2 or I1 or I0 is assigned to out. This is how the program is written using conditional operator for 4:1 multiplexer. Thank you for watching the video.